So as we continue our discussion about the nature of graphs, and we just discussed continuity and how a graph, through the middle portion of the graph, if you will, either is discontinuous or is continuous, we now want to talk about how the graph more or less finishes on both sides. Now, this is called end behavior, and we're going to discuss end behavior in particular about polynomial functions, because when polynomial functions are written in standard form, they go from the highest exponent down to the constant value, and this creates a certain pattern that takes place at the end of each of the graph, going to infinity and also to negative infinity. And so if we can recognize these given parts and these patterns, we can tell what the graph should look like before we even graph a function or deal with a function. So we're going to just take a quick look here at the different types of end behavior. Now, so I've given this to you in two different methods. I've given it to you in table form, which is more mathematical. And then when we get down here below, you're going to see a visual form to the same information that's given to you in the table. But let's define a few things here first. So if we write something, a polynomial in standard form, it's going to be, and we have a generic look at one, but I'm going to go ahead and just write a quadratic in standard form as opposed to the conceptual version of it. So if we had, 2x squared plus 3x plus 1, what we're dealing with here is you can see that the highest exponent, x squared, is first. Then we have an understood x to the first. And really what you have at the end is called the constant value. This is really x to the 0. And if you recall from exponent properties, anything to the 0 power is just 1. So x to the 0 is just 1. So thus it's not written. So if we write it from highest exponent down to lowest exponent, the highest exponent value when the polynomial is written in standard form is called the degree. The degree of the function is one of the factors that we're looking for to identify the pattern of the end behavior. The second thing that we're going to be looking for end behavior is the coefficient that's in front of the first term. And so you can see we have 2x squared, and so the 2 is called the leading coefficient. Now if you look at our table, you can see we have 4 possibilities for the degree. They can either be even or odd, and we have a couple possibilities for leading coefficient, positive and negative, and that leads to 4 possible combinations of the degree and the leading coefficient. So what we want to do is identify what the behavior of the graph is as it approaches positive infinity or negative infinity along the x-axis, and that's what the final 2 columns are telling us. Now if you want to look at this in a visual sense, we can look at it here, and so we can see on the left hand side if the degree is odd powered number, there's a general trend to what's happening with the end behavior. So if the leading coefficient is positive, it's going down on this side and up on this side. If the leading coefficient is negative, it goes up to that side and down to this side. And so these are general trends or patterns that you're going to want to identify with an odd degree and a positive or negative leading coefficient. Now, you can see over here on the right that if the degree is even, that both the end behaviors go in the same direction. And so in this case, with a positive leading coefficient, it's going up, and then with a negative coefficient, it's going down and down. So these are some general trends and patterns that you'll definitely want to look for and identify, either by looking at the actual function's equation or by looking at the graph. And so end behavior is a good part of a nature of a graph to understand. So let's take a look at sample problem number 2. Go ahead and read the directions and try to identify the basic end behaviors of part A and B. Okay, so if I'm looking at this, I'm looking at f of x equals negative 2x to the third. The first thing that I want to look at is what is the degree value. And so the degree in this case is an odd degree. Then the second thing I want to look at is the leading coefficient. In this case, the leading coefficient is negative. Now, I could use this information and go back up to the table and look at my odd degree negative, and it tells me simply that as x approaches a positive infinity, that my f of x value approaches a negative infinity. And so you could use the table to get that information. Now, you could also use simply a graph. And so you can see here, negative 2x to the third, that as we approach a positive infinity on the x-axis, that our f of x value goes towards negative infinity. And then I have to come up with the other part of this as well. So as x approaches negative infinity, the f of x term, or the y term if you prefer, approaches a positive infinity. Okay, so check see how you did on that, and then let's go ahead and do part B. Notice part B has the same properties as part A did. So the degree and the leading coefficient are the same. So despite us not knowing at this point what this particular function would look like when graphed, we can quickly make the assessment about the end behavior of the particular graph. Okay, so that's just a quick little introduction to end behavior of polynomial functions.